In this video, you are going to learn how to 1. Define the term slope. 2. Find the slope of a line given a graph using the formula rise over run. And you will know more about that when we go into our example. And 3. Interpret the slope given the situation. All this is saying is that what does the slope mean in this situation? What do we know about a slope? What is a slope? The slope of a line measures the steepness of a line. Basically, it is saying how steep that line is. The variable m represents the slope. So normally the formula is m equals to, so we have different formulas to find the slope. We have rise over run, change in y coordinate divided by the change in the x coordinate, and also we have y2 minus y1 divided by x2 minus x1. Whether you see the word slope or the variable m, all you're asking is to find the slope. M is used to denote slope or to represent slope. Even though we have several ways we can find the slope of the line, the focus in this video is to use the formula rise over run. In other videos, we will explore other ways using different formulas to find the slope. Using this example on the screen, it says, Jack graphs how far he plans to bike over a 3-day charity ride. Find the slope of the line. This is the line, and we are going to find the slope. But before we can go into our example in finding the slope, first you need to understand the graph. Let us try to interpret and understand some basic thing about the graph. On this graph, we have two axes. We have the y, which is a vertical axis, and we have the x, which is the horizontal. The horizontal axis represents our x. We have our x coordinates on that axis, which is the same thing as run. Our vertical axis is the same thing as rise. We have our y coordinates on that axis. What does the horizontal axis represent as it relates to this graph? So this graph is about Jack's charity ride. The values on the x-axis represent the days he biked or ride, and on the y-axis, the values or the scale on the y-axis, which is a vertical axis, represents the distance he biked or ride in miles. So we are comparing two things here on the graph: the number of days he ride and the distance he traveled in those days. Before we calculate or find the slope, we should have an idea what our slope is going to look like as it relates to whether it's going to be positive or negative. How do we know that? We look on the line. If that line is trending upwards, that means our slope is going to be a positive slope. The answer must be positive if the line is trending upwards. Just like in this example, the line is trending upwards, therefore our slope is going to be positive. If the line is trending downwards, it means that our slope, when we find it, is going to be a negative slope. Now, how do we find the slope using rise over run? All you need is 2 points, and points are location on the graph. All you need is two points on the line to use the formula rise over run. I am going to use these 2 points, this one to my far left and this second one right here. Using these 2 points, I need to get from this first point to this second point using rise over run. All it is saying, how many times am I going to rise and run to get to that point? So in doing this, you need to pay close attention to the scale. You must know how many units you're rising and how many units you're running to get to that point. If you look at the scale here, here is the origin, 0, and here is 20. That means halfway between 0 and 20 is 10. So each of these is 10 units. From here to here is 10, from here to here is 10, from here to here is 10. So one side of the square is 10 units. Now, looking at our x, from here, this is the origin to here is 1. That means halfway between 0 and 1 is 0 0.5. That means one side of the square here is represent 0 0.5. With that being said, let us see how we use rise over run. So as I said before, you are going to choose 2 points on the line, right? 2 points on the line. We are going to use rise over run to see how we move from the first point to the second point. When you use rise over run, all you're doing is creating right angle triangle to get to that point. So many times do I need to rise and run to create a triangle, a right triangle to get to my second point? This first point here, I am going to go up. This is 10, as we said before, 20, 30. So I am going to go up 30 units. So my 30 units is my rise. Now, how many units am I going to run to get to the point? So I am going to run 1 unit. As you see here, from here to here is 1. So I am going to run 1 unit, I run 1 to get to this point. Now, to get my slope, I divide my numerator by my denominator. So 30 divided by 1 is going to be 30. And if you notice here, when I use the rise over run, it forms a right triangle, right? So let's go again. To use rise over run, choose 2 points on the graph. Ensure that you understand the scale that is on the graph, because that's what you're going to use to see how many times you rise and how many times you run. So again, we rise 30 based on the scale, 30 units up, 1 unit on the horizontal axis. And that is how you use rise over run to find the slope of the line. What does this slope mean as it relates to this situation? So the graph is about Jack's charity ride. So the slope mean in this situation that in one day, Jack bike 30 miles. So basically he's biking 30 miles per day. And that's what it means in this situation. When you're interpreting a graph, you interpret the graph based on what you are comparing and based on what the title of the graph, right? This is the title, based on the title of the graph, because this title tells you what the graph is about. And based on the things that you're comparing here, we're comparing the number of days that we said earlier to the distance e-bike, which is in miles. So interpreting the graph, that's what your interpretation is going to be about. Here we have a key point. Note briefly at the bottom of our screen, it says, in proportional relationships, slope is the same as the unit and constant of proportionality. What do we mean by that? Looking at this graph is a proportional graph. There's a proportional relationship between the number of days and the distance it by. By looking at the graph, you can tell that it is proportional once 2 conditions are met. 1, it must be a straight line. And 2, that straight line must either start at the origin, like we have here, or passes through the origin. So sometimes you might see it like this, going through the origin. Once those 2 conditions are met, it is proportional. Proportional means that the ratio that relates these 2 quantities, the days to the distance it travel, is equivalent. What does that mean? So this point here, my first point, if I should label it, it's going to be when x is 1, y is 30. How do we get that? This is where the x and the y meet at this point. It meets when x is 1, y is 30. If I take all my points on this graph, if I take this, and any other point on this graph, and I divide my y by my x, I will get the same ratio or the same value. That is the reason why it is proportional. It is constant. It is not changing, right? So look, let us try it. So 30 divided by 1 is 30. 60 divided by 2 is 30. 90 divided by 3 is also 30. So all the ratios that relates the x and the y quantities is proportional. That means for every 1 day, it is 30 miles. Hence, it is proportional. So if you notice, the constant is 30 because every time I divide y by x, I get 30. That is a constant. And also the slope is 30 because when I use rise over run and divide rise by run, I get 30. So we realize that the slope and the constant is the same. What about the unit rate? What do we mean by unit rate? So a unit rate is the ratio of two different units with a denominator as 1. Let us try to find the unit rate of this graph. To find the unit rate, it is the miles over or divided by the number of days, which is the same thing as saying distance divided by time. So as we said before, the unit rate is the ratio of two different units. The two different units that we are looking at here is miles and day, or you can say distance and time, because they represent the time that he traveled. In unit rate, the denominator is always 1. So basically what we're doing here is finding the distance he traveled in 1 day. So in 1 day, he traveled 30 miles. So if you notice here, it is the same thing as the slope and the constant of proportionality. If you don't want to use the first point, let us try finding the unit rate. Unit means how much for 1. So let us say we take the second point, 60, which is y divided by x, 6 divided by 2. If we do that, we will still get 30 over 1. How do we get that? 2 divided by 2 is 1, and 2 into 60 goes 30. Again, slope, unit rate, constant of proportionality. Once the graph is proportional, and this only happens when the graph is proportional. Once the graph is proportional, all three are the same.